Okay, it's 1 o'clock. It's Tuesday. That means it's time for another HDF clinic. Welcome. My apologies for those of you who showed up here last week and we didn't have a meeting. Unfortunately, some of us were tied up in a workshop, and so this is the last one for this year. So don't come back next week. But however, do come back on January the 4th in the new year, and when we will have another clinic. Okay, I checked our worksheet earlier. There weren't any questions, so I'll just press on, except for I'm going to pause for a moment and ask for those who are in attendance if there are any questions right off the bat. Otherwise, yeah, we'll pause many more times. And okay, so I still owe you an answer to this question. I haven't had the time, but that's a good New Year's resolution. I think I'll figure that one out over the new year. So hang in there. And then we can look at announcements. Interesting enough, there weren't any announcements. However, there will be one. So I hear probably most of you heard about this vulnerability in the Java log4j library, and that does not directly affect HDFu, for example, or the HDF Java related products and libraries and so forth. However, there will be sort of a release with the latest versions of that log4j library. So stay tuned for that announcement. And but again, there is no vulnerability per se. HDF products that use log4j are not really vulnerable in that sense. So yeah, but nevertheless, there will be a re-release with the latest version of log4j. Okay, so no announcements otherwise, which brings us to the forum. Let's see. There was an interesting thread about memory management and conversions of variable length data types. The user was basically asking, okay, I'm reading data represented as a HDF5 variable length sequence, either as part of compound type or just a variable length sequence type or something like that, which means that, yeah, this is going to inevitably lead you to HVL_T, at least for users of C, C++. And so I just copied that struct definition here. So the way these variable length sequences are represented is basically a count that counts how many elements there are in that sequence, and then basically a pointer to a buffer in which that sequence data is stored, element by element. And so the question really goes to, what about this field called P here, this void star pointer in C? Of course, when I'm reading a variable length sequence, a data set that involves some kind of variable length sequence type, then the question is, the library will have to allocate buffers on my behalf, on the caller's behalf, because the library obviously, this length, this sequence length, that's why it's called a variable length sequence, can vary from element to element. And so I cannot know a priori what the lengths of these individual sequences will be. So I can't really pre-allocate a buffer that will fit exactly what I need. There is no function in HDF5 where I could sort of do a pre-scan and say, tell me how much data I'm looking at and so forth. This is not how the API works. So, which means that the library will have to allocate these pointers, these buffers, to which these pointers then point on my behalf. But then the question is, okay, once the library returns to me, let's say, an array of these H5VLT type things, who owns that memory? Am I, as the caller, the owner, and which means that I am responsible for freeing / deallocating that memory, or does the library do that for me? That's essentially the question that the user was asking. And the answer is very clear. It is the caller's responsibility. So as Colin Powell used to say, you break it, you own it, you call it, you own the memory. So yes, you are in charge of that memory. And if you don't free it properly, that's a resource leak right there. And in the HDF5 API, there are two functions that there was a slight shift between sort of the 112, pre-112 HDF5 library versions and then HDF5 112 and higher. In pre-HDF5 112, there is a function called h5d vlen _ reclaim. And what that does is basically what you would intuitively expect it to do, which is traverse that array, that buffer of HVL _ t's, and basically call free on all these buffers, and that way make sure that nothing leaks and no resources are used that you are no longer aware of or that you no longer need. And then this function was renamed h5t reclaim in HDF5 112. The reason was probably that you could argue and say, well, this is really more something that's more related to the type, to the element type of a data set than to the data set itself. So it switched from call it the H5D, the module that deals with data sets, to the H5T module that deals with data types, thinking about variable length sequence data types. Okay. And so that's pretty clear. The caller owns it and has to make sure it gets properly freed and deallocated. Okay, I'm going to pause here and ask, are there any questions so far about something completely different? If that's the case, speak up.
Gerd, if you want to put this in the queue, I just had some general questions on get user block. Just in terms of usage, what typically gets stored in that? Is it heavily used, or is it generally available to put whatever you want in it? Just a usage pattern on sort of what the expectations are. I didn't see any examples in the man pages, so I was wondering what the possibilities are for that function.
Great. Well, let's talk about it right away. Okay. Thanks for asking the question, first of all. User blocks, just as you said already from the definition, it is really the idea that if you take an HDF5 file, then normally or typically even the sort of the formatting information
We lost sound.
or some of the other image formats do the same thing. They have sort of magic marker, so to speak, at byte offset 0, if you want to think of a file as this linear byte stream. And that's the typical use case. However, at some point, people were asking and saying, hey, this is an HDF5 file, and that's great, but I would like to perhaps embed content into that HDF5 file that can be sort of discovered and parsed and understood, even in a context where I either don't have the HDF5 library available, or I want to make that file appear as something different altogether. So the requirement was, how can I jam or stuff something into that HDF5 file that is useful without HDF5 potentially for applications, legacy applications, other applications that really don't know anything about the HDF5 library. Can that be done? And if you think about it for a moment, that is actually not that, it sounds easier said than done for the following reason. Yes, we have, for example, this thing called an opaque data type, which is just a sequence of bytes that's uninterpreted. So you can certainly put blobs, binary large objects, into an HDF5 file as data sets or attributes, what have you. But of course, the problem with that approach would be that the library would put that blob, that byte sequence, somewhere inside of the HDF5 file. And now if we think back to our requirements, the requirement was there is no HDF5 library to discover that data set. So that is not going to work. So opaque types don't solve this problem. So somebody came up with the ingenious idea to say, hey, since we have this magic marker, this signature, this HDF5 signature, what if we could just, instead of insisting on that this magic marker sort of lives at byte offset 0, what if we just had a set of predictable places where to look for it? And because if we could do that, we could sort of create room for ourselves where we tell the users, well, if you want to set aside some space for your discretionary use and the HDF5 library will not interfere with it, it will just ignore whatever you put into that space. If we could do that, then we would solve this problem. And that indeed was the birth of the user block. And as I said, we need some predictability where to then find the HDF5 file format signature. And as the manual says, the convention is that the signature can be offset at least, it has to be offset at least by 512 kilobytes. So your minimum user block size, so to speak, is 512 bytes. But then after that, it can be any power of 2. So you can have a kilobyte, 2 kilobytes, 4 kilobytes, and so forth. So if you need a large user block, it can be gigabytes. If that's what you want, that's fine. So the user block can be anything that's greater or equal to 512 bytes, and any power of 2 bytes after that. There's no upper limit. The upper limit is really only how big the files can be in your file system or something like that. And so this is the idea of the user block, is really users have the ability to create a compartment, if you wish, at the beginning of a file where they can put whatever they want, and the HDF5 library will not look at that space, it will not touch that space. It's completely at the user's disposal. Now, the question is, well, why is that a good idea? Give me an example of in which context this is useful. Well, some people have used this feature, for example, to embed, for example, think of a library. In the old days, when you went to the library, there was a big catalog, and for each book, there was sort of an index card. And let's assume that index card is like a small text file. So what you could do is you could, for example, create such a small index card as a small text file and put that into the user block. Or you can take that to the next level. You have a cell phone and you can take a picture, or you can generate a barcode, for example, and that barcode is going to be a small image file that you can also put into that user block. So there is really no restriction. And again, you can take that really to the next level, so to speak, where you can embed entire documents, let's say, that are formatted in other formats, like PDF files or even Word documents, you can jam them into that user block, and that creates sort of an intriguing situation. I'm going to mention it, but I'm not necessarily recommending it for everybody. What you could do is you could, for example, take a Microsoft Word document or an Open Office document and put that into the user block. And what that would achieve is that to the Microsoft Word application or to the Open Office, I forgot already what the Word counterpart of Word in Open Office is called. To those applications, this file would appear like a Word document or an Open Office document. However, to HDF5, it's just an HDF5 file. So you can, in a way, create sort of interesting hybrids where they appear as one thing to one application and as another thing to another application. Now, why I wouldn't recommend that necessarily is that in a way, that hybrid, of course, works only if the other application sort of doesn't transgress or trespass onto the HDF5 file, because many applications, I think Word is an example, it will actually look at this file and say, okay, let's say we have a 1.3 megabyte Word file and our user block is 2 megabytes large, and then we have a 16 gigabyte HDF5 file coming up after that. What Word will be tempted to do is it will start recognizing, oh, this is a Word document, and start reading it, and will say, oh, this is only a 1.3 megabyte Word document. And then there's this garbage at the end, which is sort of your HDF content. It might actually decide to truncate that document and say, well, that's just unused file space that somehow got allocated, but I don't really need that, and will sort of truncate the file. Of course, if that happens, then you are in trouble. And so unless you have some kind of, either that the user would open that Word document read-only, or you have some kind of protocol to ensure that applications that do not know that you are playing this game, they might potentially sort of interfere with this. But it opens a lot of possibilities. I think in the simplest case, yeah, think of it, you can then, for example, in Unix, you have the head and tail, so you can look at the end of a file or the beginning of a file with the head command. So if you just want to peek at the index card of an HDF5 file, so to speak, and let's assume you have embedded that little snippet of text or a barcode or something like that, you can quickly peek at that and know exactly what you need to do without any need for the HDF5 library. Does that make sense?
Yes, that's quite interesting. And it could be resized, but then you then assume responsibility for duplicating whatever. In other words, if I were opening up a user block and then planning on adding to it or adding something that was maybe unrelated, but I wanted to use another section, I would just have to be careful not to tread on whatever was there, but I could resize it and rewrite the file.
Correct. Yes, yes. So you are really, if you are using user blocks, so to speak, and with some dynamics to it, let's call it that, then yes, you are taking responsibility. And again, in some cases, that's exactly what you want. And there's no magic here. It's well documented and understood in a way. But there are, especially if you work on projects with other teams or other team members who may not have that level of understanding, or they may not exactly understand what's going on there, they might actually by accident do bad things to your HDF5 files. And you know.
But it's almost a way of, you can keep the HDF portion essentially read only if you and still change the user blocks. So if you were looking of putting your index cards in there, if somebody wanted to make modifications to the index cards, they certainly could, and the HDF5 remains completely untouched.
Yes, yes, yeah. This could be, for example, let's think about archival, for example. If you wanted to create a collection of HDF5 files and just sort of put it down as an archive, and let's say, but then if you, when you use that archive, you would like to have a query interface or something like that, that literally lets you quickly scan that catalog of library cards and so forth. Yeah, then you could have a simple application that just walks over the HDF5 files and just looks at the, let's say you have a maximum size of index card, like on an index card, you have usually a maximum number of lines or something like that. Right. And you could just extract the index cards from all books and in a way recover the full library catalog should by a mishap you ever lose that library catalog or something like that. It would still be in your archive and you could recover it relatively easily.
Yes. Okay. All right. That's very good. That's a good start. That the possibilities are almost endless.
Yeah, but there's a danger again. It's really it's a double-edged sword.
Yes, you still need some agreement if you do have a protocol for using the user block. It has to be published somewhere. Yeah. So folks know what is there and how to behave when they're looking at it.
Yeah.
Yes. But the fact that it's available is quite interesting.
Mm-hmm.
So okay. All right. Thank you for the. I apologize for the diversion.
Oh no. That's why we are here. I mean,
okay. Okay. Well, this is good. Thank you.
Thank you. All right. Well, then let's press on here. There was another question about reading or writing a compound type, and the user just happened to put, instead of a char star to represent a string, or a const char star, a fixed size array. They said, hey, why can't I put a C++ STD string in there? And the user also reported that actually, intriguingly, he modified one of the examples that's sort of published with the HDF5 documentation. He actually said, interestingly enough, the right portion of that program where we generate basically a data set with a compound type that looks like this, where you have an int, a string, and two doubles. The write portion worked, but the read portion didn't work. And so just in general, I would say, number one, it's definitely a bad idea to pass any kind of C++ objects as arguments to C library functions. The simple reason is that how these C++ objects are represented in terms of their memory layout is completely at the discretion of the compiler, the C++ compiler, and different C++ compilers do different things. So the thing is, yeah, if you get lucky, that's good for you, but you are really relying on a sort of a peculiarity of that compiler. And I can assure you that your luck will eventually run out, being you switch platforms and use a different compiler, or the implementers of that compiler change their mind and change representation. So, for example, I linked here, this is a very interesting article where somebody describes the representations, the compiler level representations of STD string. And right there, you can see that the writers make all kinds of optimizations depending on if you are dealing with a short string, or I think the definition of a short string is, I think it can be up to 22 characters or something like that. But then the representation actually changes for longer strings, and that's actually only true for G++. And so again, this is just one more detail that even if you get lucky at some point, that's that's just dumb luck, as they say, typically, and don't rely on it, don't count on it. As a rule, don't pass C++ objects as arguments to C functions. Okay, one more, I think there was one more. Yes, someone was asking, and initially I didn't understand what the person was asking, but then he elaborated, and I think I got it. So someone said, hey, I have two groups, and these two groups have the same structure as the person formulated it, and they would like to merge the contents of these two groups. And sort of after a little bit of back and forth, I understood, I think, what they wanted. So let's just pretend that we have a group G1, and then we have a data set D in there. And then we have a second group G2 and a data set D in there. And then I think what the person was trying to achieve is to say, let's say, hey, let's create another group, or that G3 could actually be either G1 or G2. And then we would like to sort of sum, I used here sum, to say, well, let's just concatenate or append G2D to G1D, or the other way around, depending on how you want to do this. And then, yeah, either append it to one of these existing data sets or create a new data set altogether. So unfortunately, yeah, this is not a default operation, just one operation. I think the person was making a reference to root, and it sounded like that was sort of a common thing that people do. But in a way, if you want, of course, you can do this in HDF5, number one. But number two, in my opinion, you have to ask one crucial question, or one question, depending on if you answer it with yes or no, you will go down different paths. And the question is, when we do this, call it append operation or merge operation, is copying data set elements potentially, is that problematic for you, or is that not a problem? And what I mean by that, well, yeah, if that data set is 10 terabytes large, and you tell me you want to copy 10 terabytes, then that may, if you have enough time, that will eventually happen, but it's just not very performant. And there could be then also issues surrounding, well, how confident are you that copy operation, that you didn't introduce any errors in reproducing it, especially if these types, the types of these data sets, they may have the same name, but let's say one is a 32-bit float, the other is a 64-bit float. So you might be in a situation where you have to drop some precision and so forth, and that may all be very fine and so forth. So there could be different definitions of what it means to be problematic, but you have to answer that question. Is it permissible or problematic to copy data? And if your answer is yes, it is a problem, which means I do not, under any circumstances, I do not want to copy any data set elements, then sort of the obvious choice in HDF5 is to use what we call virtual data sets. And they also provide you what I would call maximum flexibility in defining the sigma. So you can, for example, concatenate them if they are one-dimensional, but also if they are multi-dimensional, you can pretty much choose an arbitrary layout how you want to embed these, I would call them constituent data sets, into this larger dimensional space. So you can embed two one-dimensional data sets into a 2 or 5-dimensional, whatever suits you, data set with virtual data set. That's with virtual data sets, and that's really just a matter of defining some mappings, and that's just metadata operations. So there are no data touched or changed. And as a side note here, virtual data sets, I believe, were introduced in in one version of HDF5 1.10. So if you are running 1.8, unfortunately, you do not have the luxury of virtual data sets. However, you can, what I would call fake virtual data sets. We have this concept of data set region references, where you can refer to a region of a data set, but also the entire data set if you like. And then you could create a data set whose elements are such region references, and you could use that. Again, it would amount to a protocol where you say, well, when I encounter a data set whose elements are region references, I understand that as I read this data set, I have to go and retrieve, dereference those region references, and that will give me the data.
Lost audio, Gerd.
You would take what I would call a pedestrian approach, which is, create a new joint data set or extend the existing data set to accommodate the data set elements that you want to bring in. And then unfortunately, you have to read either both or one data set and write the elements to the destination. The only, again, wrinkle here is that if these constituent data sets are very large, and by large I mean so that they do not fit into memory, then you cannot just read the whole data set and then just write it back. You will have to make hyperslap selections, so to speak, and then that way bring over the data. And so those are basically your two choices. In one or the other case, you might want to go with one or the other option. Certainly virtual data sets, if you can use them, is the most convenient way. The only thing is, if these constituent data sets are tiny and you are thinking about not just having two of them, but thousands or hundreds, then the overhead is going to be substantial, because you're piling metadata on top of metadata and so forth. And then if you want to make selections on such a virtual data set, that's not going to be very performant. And I'm afraid we are out of time. I had prepared a little something that I'll show you next year, and I'll have some time to actually develop it a little more. Anyway, I would, on behalf of the HDF group, I would all wish you a very Merry Christmas and a Happy New Year. And I hope you come back next year and we'll have more interesting discussions and questions. And thank you.
Gerd, do we have a session next week?
No, we don't have a session next week. So we are coming back January 4th, which I believe is a Tuesday. Yeah. Okay. Thanks. Take care.
Thanks,
Bye.
everyone.